Good morning, people. In today's video I will try to talk a little bit about something I couldn't find much information about online, specifically for 0.2 nozzles, because I can find a lot of information or several videos around what's called MAX volumetric flow, which is when you click on the filaments and you go to the filament settings at the bottom, you have this here. This is something that is relevant very much to, just as you have calibration of flow and calibration of K value, which is like dynamic pressure control. The reason I started looking into this is because I've been using a new filament, which is this one. This is white PLA from Claes Olsson. More precisely, it's made by Flashforge. So if you have Flashforge white PLA, then it might very well be the same one, because it's made by the same company. Now, the problem I've been facing is PLA usually you can print with a high speed, but when it comes to this specific one, I have really struggled with every single print I've tried to print. Have almost ended up in clogging the nozzle, and I'm not talking about like an easy clog you can remove. I'm talking about like having to do like 10 cold pulls and using a needle pin and everything just to try and be able to print again with it, because it almost chars inside the nozzle. And I used to think maybe it was too hot, or maybe it was too cold, so I tried a lot of different things. So in the end I went to my friend ChatGPT, and I spent a lot of time researching a lot of factors, and there was a lot of interesting things that I found out during this these things. I'm just going to try and go through a little bit of those things today, and the whole video is basically gonna revolve around 0.2 nozzles, standard settings, and calibrating max volumetric speed settings for your filament, and for 0.2 nozzles, because I can find tools online for 0.4, but there's very little information about 0.2. And there's going to be some things here that you may not agree with. There's going to be some things here that may be wrong from my perspective. I'm basically supporting my findings here on what ChatGPT is looking up online for me, and listing down formulas that it's using based on information you can find on websites. Sorry. So that was a little bit about what's going to be going on in this video. So first and foremost, there are two really important settings you need to know about. The first one is under cooling. If you want to do the tests I'm going to show you today, and yes, I know it's a lot of layers. I will get to that later in the video, hopefully. This setting here, slow printing down for better layer cooling, you should untick that box. That's one of the things, because that setting almost will also make it impossible for you to see the calibrations we are going to do. Now the next thing will be under filament. If you cannot see the gradients of the calibrations we're going to do, then it may be that your volumetric speed max cap is too low for what we're going to do. So If we're going to do a test that requires the max cap to be 12, but you have it set to 1.6, then you will basically just see the first gradient on the thingy, because you need to set it to 12 down here to be able to test with that. I'm going to show you later in the video. Okay, so those are the two things that you do. Now, the thing with max volumetric speed is that it is a setting, as far as I understood, that the printer determines based on the speed and the layer height. So you will be using a formula that is basically volumetric speed. Let me see, the formula is layer height times layer width. No, hang on. Let me see if I can find my ChatGPT window and look it up for you. Give me a second here. So basically, the formula you use to calculate the volumetric speed is layer height, line width, and print speed. Now, line width will always usually be the same. Layer height will always, for the most part, be the same. But the one setting you usually change is print speed. And usually you can say that you have a print speed equals a certain amount of volumetric speed. And the reason I say this is because if you set a print speed, then it starts printing at that speed, and it will use a certain amount of volumetric speed to put pressure out of the nozzle when it do that. But the problem is, if you have a very low volumetric speed, let's say you have a 1.6 maximum cap set for your nozzle, like I do in my filament here. Let me see. Here, I have it set to max 1.6. And then I set the print speed to be 200. And basically, I will be under extruding, because the print head will move so fast compared to how fast it can push filament through the nozzle. Now, you would think that I'll just increase the pressure. I'll just increase the volumetric speed and it will be fine. It is wrong. That's not what's going to happen. Because imagine you have a banana and your idea of the nozzle is a straw. So you have this banana, which is kind of hard, and you want to push it through the straw, but as you do that, you want to squash it. You need to squash the straw to sort of mush the banana on the way down. That's the melting in this case. So you keep pushing the banana down, but you cannot squash the banana fast enough. So what happens is that you are filling the chamber with too cold filament, and the print speed is really high, so basically you're running out of filament, so it's under extruding. But it's kind of more complex than that, because each nozzle size has a maximum amount of extrusion that it can cope with to manage to print. So let's see, this is an example of if you are setting various things. So reliable everyday 2.5, fast but stable, but these values that you see here are not necessarily true. But it says that if you have a volumetric speed of 2.5, then your maximum speed is 100 ms. If you have 3, the maximum speed is 120. If you have 3.5, the maximum is 140. But, and this is a big but, The general maximum speed a 0.2 nozzle can push out is around 40 to 50 cubic millimeters per second. So any speed higher than that will cause issues. That's why a 0.2 nozzle is slower to print with. And how is this relevant to our testing? Let me check my notes for a second. Okay, so the relevance is that you will rarely print with a speed of 5 when you have a 0.2 nozzle, because there's a lot of factors that is involved in this. How fast it can heat the filament, and how fast the printer can print, etc., etc. So you're going to use a formula usually to be able to print this. And I mentioned this formula would be here. So you have to find the correct volumetric speed in cubic meters, you take the layer height, the layer width, and the print speed. So in my case here is an example 0.1 millimeter height, line width is 0.25. In this case that is not entirely correct, so I'm gonna see if I have it at 0.22. I did ask it for here. Let's see. Here I said change to 0.22 line width. Volumetric speeds is then 1.5 to 4.5, and that's so here you see how it calculates. So if you have 1.5 in max volumetric speed, then that exact max cap equals 68 millimeters per second in speed. If you have 2.0, that equals 91 millimeters per second. If you have 2.5, that equals 114 millimeters per second. If you have 3, it's 136. And these are caps. If you have it set to that, you cannot print faster or you will have issues. Okay? And 3.5, that is 159. And you're starting to get into an area that most printers cannot really do at that nozzle size. 4 is 182 and 4.5 is 205. So if I set the cap for this filament to 5 and I set the print speed to 200, it would be able to cope with that. But if I set the print speed to 300, it would be too high a value for the pressure behind pushing in filament into the extruder. Now remember I said that the max print speed is 40 to 50 ms. That is because for most 0.2 nozzles this is even a high value. 1.5 is really a high value because you need to have a balance between everything when you try to print. And let me see, I had some other tests I did here. I'm just checking. So here you can actually see, let's say you want to print a detail with a 0.2 nozzle and you want to print it slow so it will be accurate. So if you want to set your print speed to, let's say, 13 ms, then you actually should be setting your filament to 0.3 in the max volumetric cap. And then your maximum speed listed, let's say for the walls, should be 13.6. So if you want to cap the wall printing to a certain specific speed, then that would be 13.6, and that would equal the flow rate that would be stable for your filament. But I know this can be a bit confusing. So what I did was I found some profiles, but none of them actually worked for 0.2 nozzles, and it took me a while to understand how they worked. So I have a black PLA. This one is really great. It can print really fast because it has a different melting point than the white. And then I have some, let's see, we can start with this one. This is the white PLA, where I tried to print with the same speed as the black. See what happens? The edge is here. And I tried even lower settings. Let's see, where's the lower settings? Here. There. Starting to bond at the bottom, but it's failing at the top. What is interesting here is that this one is a test I did between 1 to 5 volumetric speed. So you see 1 at the bottom, and then you have 5 at the top with corresponding speeds. I don't have anything for this one that I showed you, but I think this was at 120 speed, which would equal a volumetric speed of what was it? 2.5 to 3, between there. Now I went lower. 1 to 2. Let me see. This is 1 to 2. You cannot really see it, but it's actually best viewed there, maybe. Let me see if I can get a picture of it. You cannot really see it, but the cracks in the edge actually goes all the way down to the 1. So this white PLA is sub 1 volumetric speed. And what does that mean? That means I have to go in even lower. Now this is a tower where I print the same PLA from a 0.05 to a 1. And I don't know if you can see it, but roughly around here it starts to come apart in the seam. Down here it's not perfect because it's under extruding, but down here it starts with 0.05, 0.01, 0.1, 0.15, 0.20. And I'm going to show you that chart in a second. Give me a second here. I'll bring it up. Yeah. So basically, I'm going to zoom this in a bit so you can see. So I started with a flow rate in my test of 0.05 cubic millimeters per second, and that equaled a speed of 2.3 millimeters per second print speed with a layer height of 0.1. And it's a really thin model. You see, it has 2 walls, outer and inner wall. And the next step would be 4.5, 6.8, 9, and so forth, up to 1. And if let's see, I can count down and see 1, 2, 3, 4, 5. So about 5 from the top. 1, 2, 3, 4, 5, 6. So around a volumetric speed of 0.75, it starts to come apart in the edge. Now, if I look against the light, it is kind of hard to see where it's best. But I would say it's about 1, 2, 3, 9 from the top. So around 1.6. Around 0.6 volumetric speed would be what I find to probably be the best quality for printing this. I'm gonna open my other camera here and I'm gonna show you in a second. There, let's see if I can bring it up. IPCam. So let's see if I can show you. So this is the top of the thingy. Hang on a second. Okay, I had to flip the picture. So I don't know if you can see. But right up here, it is starting to come apart. So one. If you wonder why the holes indicate where each of the layers are. So 1 layer, 2, 3, 4, 5, 6, 7, 8, 9. So this layer here is around the best one. And this is basically 0.06 volumetric max speed. And for this filament, that would roughly be the... It's still good at... What is he? There's no tearing on the edges at that speed point. And let's see. Yeah, it always comes back to number 9 there. So in my case, if I wanted to have perfect prints with this white PLA, I would need to also set a max cap of 0.06. But it says too small volumetric speed, so it cannot go that low. How low can it go? 0.8? 0. I think let me see, what did my chart say? 0.6. Sorry, it wasn't that low. So here, 0.6. That is my max volumetric speed cap. And what does that mean for speed? To be able to print with really good quality with this specific PLA with a 0.2 nozzle, I would basically have to go and set a max speed, which would be 27.30 mm per second. So I can take this value and I can just rename my VS 2.37. So if I want to print well with this, I cannot print with a white faster than 27.3 millimeters per second. And that is really significant because it means that with a 0.2 nozzle, this white PLA basically will start to bring artifacts if I print faster than the 27.3 that I have to print with. Now, how do I set this for my print? Basically, if I then go, I have saved these settings now. If I say, okay, I want to print this perfectly every time, then I go into the speed settings and I said, okay, I don't want to print faster than 27 point wait, it's gonna be different here. I need to do that for the objects. Let's say I have a multicolor object, then for those that have, let's say most of these are, let's just say they're black, most of them there, but that one and that one and that one are supposed to be white. Let's just say that. Okay, now for the white ones I would have to go and set this specific speed to cap the print to the 0.6 volumetric speed when I print it. That means that when it gets to those layers, it will print with 27.3 and it will give me the exact same let me see, it will give me the exact same print quality I had at 0.6 here. Now there are some, the way you read this that I found easiest is, one, you have to look when it starts to tear here in the edge. And then you have these nudges I did first and foremost to see each layer. These holes represent each layer, but they also give you a representation of how well it bridges. So if you look here at the bottom, the bridge is kind of, see if I can get it to zoom. It looks kind of bad. But then it gets better as it gets up. When you get around the area that's good, like you see here, then the bridges are perfect because you need a certain speed to make bridges, and to avoid them from sagging, they need to cool in a good manner. So if basically you're printing too slow, when you get to the second pass, it basically the previous bridges sticking on the previous filament, so it's sort of dragged up a little bit. So that's why you get the the weird hole at the bottom, but it gets better as you get up. So those are the things. Now the next one is you can take some light. Let me see if I can find some light here, like this. And then you can look for the shine on the side of the thingy. Like at the bottom, it's okay, but you can see there is like under extrusion a little bit. And then you see, you can see the lines. And then you get up to around the middle, which is here. Then you have an almost perfect surface without seeing any layer lines at all. And there is no gaps in the edge here. And that is the 0.6 max volumetric flow setting at that specific speed on a 0.2 nozzle. So that's how you read the towers that they made, these ones. Now next comes the how do you use the towers? Because let's see, I saw some of these explanations online, but it wasn't so easy to understand how to actually read it. So I'm just going to go through it really easy here. So I have made some predetermined models. All of these models is combined of several objects that are stacked in height, as you can see here. This one is for black PLA. And let's say you have a different kind of PLA you want to test, then it's not a problem. You can go and you can change the type to, let's say, a different one, and then you can just adjust the settings. But you have to do that specifically for that setting, let's say. So if you uncheck it, it will sort of lose the settings of the tower, and you just need to set that again. But to do that, I have given some tips. I will release this XLS file, which is a Excel file, and it has some charts in it. So if you have a 0.2 nozzle and you want to print at 0.08 millimeter height, and then you want to print at a flow which is 1 to 2, then basically you have some core settings here. You can use this as the base test for your filament. You can also set it to a little bit higher, like if you have 1 to 5, you have different values here. If you want higher speeds, you can check how well your filament performs. Likewise, I'm just gonna max this. I made charts for also for 0.1 and 1 to 2 flow. So you can see there is different settings for different speeds. So let's say in this case you want to test a flow rate that's between 1 and 1.9 with a 0.2 nozzle. Then you go in and say, okay, I want to have these values here. That's what I want to achieve. And then I need to get these print speeds here. And then, of course, you need to have preset the layer height. So let's say I want to use this one, and I need a total of these number of rows to configure. So let's see, how many rows are that? It's 11 rows. Then you can go in and you can find the, I'm going to release the 3MF file of this as well, so you can see it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is an example of one that I have used. So it's this one. 1 to 2 flow rate increment 0.1 blah blah blah, but you can just use that same model. So let's say you want to do your own test, you can just copy that whole thing, make a new, and paste it, and then you can go down and you can start at 0. Now it will have brought in the values from before, but you can just do like this, and you just reset those to default, just first so you see what you're working with. Then you go in and you say, okay, I want to test with 0.8 first. Okay, so you want to test with 0.8 layer line. You go in and say, okay, 0.8, 0.8. That's wrong. And for 0.2 nozzle, I do not ever recommend going below 0.1 on the first layer, because you need adhesion. It's very important. I have had several adhesion problems because I lower below 0.1. So 0.2 nozzle, don't go below on the first layer for layer height. So you only change layer height, which is the top one, to 0.8. Okay, so that's the first change in this test. Next, you go to the speed section. No, you go to the object sections up here, because you need to change this per object. Okay. You can also, yeah, you cannot change the layer height inside here, so you need to do that in the main settings. Then you go to the first one. The first one should be equivalent to, let's just say I want to test this one, 2.1, and then I need to start with a speed of 138.31.20. Then I go into the first one, speed, and I just change everything to that settings. Okay, and then I go to the second one, and I take that value, which is a little bit faster print speed, and I go to the next one, same there, there. I forgot to say, set the type of filament first, because it follows the filament when you are doing this. If you change the filament, it will reset the settings for speed. Okay, so that's the 5. Is that the 5? I feel like I'm one behind now. Let's check it again. 1, 2. Supposed to be other 2. 1. I forgot one. Wait long. That one's supposed to start there. I felt I was behind a little bit. In my guide, I have set the previous plane to be the same as the 0. So here it starts at 0, 1, 2, 3. That is 0, 1, 2, 3. So just you don't get confused. So 1.20. Okay, and then the next one. Is that the third? Okay, so I'm just gonna pause here and I'm gonna time skip and put everything in. Okay, so I time skipped a bit for you guys. So I have now placed the values that you can see here. I'm just gonna see if I can make it a little bit like this. So you can notice I have input these values here, and then it's for the first one. Let me see, I'm gonna just mark it. For the first one, it's plain 0, that's 125, and then it's 131, and it's 137, 143, 150, and each of these speeds equal a maxometric flow set to these values here. So if you configure filament to have any of these, then this would be the max speed you should perform with that filament. Ora. Pappa lager en video. Kan du lukke døra til pappa? Tusen takk. Do a check of these settings. From 36, 16, 38, 17, 40, 43 og 45. Okay, so I verified the values now. If now slices, it should look nice and smooth. So here you have a perfectly graded tower, and that is actually what I printed. I must have changed the values in between. And what you get now is actually the values from this print sheet. So the first layer at the bottom will print with a speed of 2.3 millimeters per second. Second, blue here, will print at 4.5. So if you're setting your like one part of your part to print at 5 millimeters per second speed, you're literally telling the printer to print that with a flow rate of let's say between 0.10 and 0.15. You're telling the printer to do that, and it will try to do that. And usually that works if you set it, but if your filament is wrongly calibrated, it will try to force as much material out as it can. So you need to have a cap on the filament. And that is my point here. In my case, when I ran the calibration like this, I found that plane 9, I think it was, let me see, 9 from the top, 1 2 3 4 5 6 7 8 9. So this is the sweet spot for my white PLA from Claes Olsson with a 0.2 nozzle and a layer height of 0.1. Now let's say you want to find something else. I highly recommend you use ChatGPT. It's not so expensive if you sub to it and you have unlimited kind of asks you can do. So it's a really good tool to use. So you can say, can you help me with a chart showing max volumetric speed with print speeds from let's say you want to check how fast you can do this on a 0.2 nozzle. Let's say between 1 and 100 mm s, and let's see, layer line height of 0.1 millimeter. In how many steps do you want? Let's say you want 20 steps. You can have that. My model here will have up to 23 steps that you can utilize. 20 steps. And if you want to follow my step, you can say, okay, please add an initial column called plane, starting with plane 0, plane 1, plane 2, and so forth for each of the values. So now it should generate a similar kind of overview, but for 20 based on those layer lines. And then you can just take those values and you can paste it into the show max 1 decimal. Just you don't want all those tiny ones. See, now it got better. Okay, so now you can download that chart and you can open it. Let's see, I'm gonna open that chart, refresh. So here is basically the chart that you can do with the same. See there. So this is how you can make your own towers and set it to the values that you want to use. So I'll just set that to 1. So if you want to make a tower, you can just use the models I have made. And in the plane 1 model, you can set, okay, I want to start at 1, but in this case, so that's the volumetric speed. It's actually a little bit opposite than what I have, so remember that. That's speed, and that is volumetric speed. And but the only thing you then need to change is your speed settings of your filament. And this should be with layer height 1. Let's see, I think that's what they said. Yeah, okay, so volumetric speed chart, So you can basically say that if you want to test your filament with speeds from 1 to 100 on a 0.2 nozzle, you could use this, and then you would get equivalent like in between. Let's say you find a range that is roughly between 1 and 1.5. Then you can take, okay, let's say I want to find, can you make a similar chart but with max volumetric speeds ranging from 1.1 to 1.5. This may be very low values though. It's just an example. So now instead of using your speed, it will basically find the speeds you need to set to get those exact values. So I'll just get that. So then you see at max volumetric speed, you would have to print at 25 for I think it's a little bit off. Show 3 decimals. Because now you will basically see why it's showing different. So now it's showing 3 decimals because I just want to show you how accurate it can be. So basically you are having here. So if you want to print at these volumetric speeds, then the equivalent print speeds to test with would be this. So if you feel your max volumetric speed just need a little bit adjustment, you can just go and you can create a new chart between two values, and you can just add those values into my model, and you can just reprint the model as a test. Now I have made the model based for a 0.2 nozzle, and you can change the layer height yourself. We'll just make more lines per height. Let's see. I will add yeah, for the Bamboo Studio users. No, it would not work because it would not split it correctly to parts. Never mind that. Just use Orca Slicer, guys. I am using Orca Slicer with my printer in is an X1Z with my printer in LAN mode. So yeah. Anyway, I just wanted to add a video out there for 0.2 nozzle and max volume flow calibration, but I have one more thing I wanted to show you. As I told you, primarily one of my main reasons to do this was because I got a lot of clogs, and I'm going to talk a little bit just quickly about why a high max flow rate can be bad. So if you set it to 5 and you set the speed to 200, just as an example, and you're printing with a 0.2 nozzle, and the filament, like in my case, this white filament cannot handle more than 0.6, then you're basically putting yourself up for a world of hurt. The biggest problem when you do that, I found, is cold filament jams, and let me see. So I'm just going to go through the various ones. It's this is why you usually get clogs in 0.2 nozzles. Heat saturation. The hot end can't melt filament fast enough. Plastic softens but doesn't fully melt, building up pressure in the melt zone. Slow heat transfer. PLA needs time to absorb heat. A 0.2 nozzle restricts how much melted plastic can exit per second. That is the max volumetric flow cap of 440 to 50, basically, because of the size of the nozzle. Back pressure buildup. Small nozzles restrict outflow, so any excess input volume has nowhere to go. This causes backflow and filament grounding. And 1 second. And I can actually vouch for that. Let me just get my camera on again and I will show you here. This is my this is 0.4 though, it doesn't matter. I'm just gonna illustrate for you. The other day I was printing and I got a jam. Thought it was the extruder, it was not. It felt like an extruder jam. But what happened here was that this on the 0.2 nozzle was that filament had literally started flowing sideways at the entrance to the hot end here. So there was literally a small blob inside here, which caused the cutter to jam. And that is, I think, I haven't got any other clue about it, but when I read this, I was like, that sounds plausible. Small nozzles restrict overflow, and any excess input volume has nowhere to go. This causes backflow and filament grinding. You know, when the extruder cannot push the filament through. And in my case, what happened was that the filament was trying to be pushed through, and it caused the heat of the filament to build up backwards, and it started melting just between the extruder and the hot end, and it started flowing in between here. I've seen several videos online where this seems to have caused like a big explosion and there's like a ton of filament coming out. I have a feeling that's what's happening. People are not calibrating their max volumetric flow for the filament, for the use they have. So they are trying to print with the wrong pressure, so they causes back pressure buildup, and you get this blob here. But it's the hot end is cooled by the fan, so that small ring here is gonna harden so much that it cannot be pushed into the hot end again. So you get the clog is actually at the top here mostly, and it prevents the filament from getting pushed in, and it also prevents the filament from getting dragged out. And so I have experienced that, I think. And I think I also had, if filament isn't melting fast enough, the partially softened filament can jam just before the melt zone. That's a cold plug, they call it. That would be in this video around here, I think. The hot end is heated here, and the filament is attempted to keep cold until it gets down to this point, and then it gets heated up here. So if it literally isn't melted fast enough, partially softened, so it creates a jam inside here. I've had a few of those where I can literally pull out filament from this part, but I have to do like 10 cold pulls to get everything out from the bottom part. Heat creep, especially on PTFE linked hot ends, sustained high flow raises upper hot end temps, softening filament too early and jamming the above melt zone. What you can sometimes see in printing is that the printer appears to be printing, but nothing comes out. What happens then is that it's trying to push filament in, but it's jammed in here, so nothing is coming, and nothing is coming out. So it's basically trying to print, and the extruder is trying to pull. So the extruder, this one keeps heating up. No filament goes down to sort of reduce the heat. So the heat actually uses the filament to travel upwards. Even though this one is being cooled by a fan, the heat becomes so high that it travels up and it starts heating the extruder. I have the Panda extruder, and I measured it to 90 degrees Celsius once. and that was after I took it out of a clog. And I also measured the back of the extruder where it's connected to the printer itself, and that was like 80 degrees Celsius, and that was like a minute after I took it off. So does max volumetric speed flow calibration make a difference? I have never been able to print something like this tower with this specific PLA until I started calibrating my max volumetric flow for my 0.2 nozzle. Other than that, let's see, I'm gonna take that away again. Common symptoms of overdriving your 0.2 nozzles: sudden under extrusion or very tiny walls, clicking extruder, tick 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 tick. You've heard that if you've had it. Filament grinds and strips. Basically, you get this. It cannot push the filament, so it's grinding off the filament in the middle of the extruder. Total clog requires cold pull and nozzle cleaning. You have to use those tiny needles to get it open, even though you're trying to do cold pulls. Gaps in the infill and top layers. I have had that. Let me show you. I'll show you. This is, believe it or not, this is ironing. I'm gonna give you some light on this. This is ironing. And that is the black, because it started clogging on white. See if I have a better one. This is a better one. So basically, you can also get what's called thermal degradation. The PLA becomes brittle and darkened. And sometimes it's hard to do cold pulls because the very tip that you want out breaks off when you try to pull it. So that can happen. Usually what I do is I heat up the temperature enough so they can get a needle through, and that is around 135 degrees of the nozzle. So I have the nozzle out, I only have the hot end out, and then I heat up to 135, and then after I've done several cold pulls, I pull the needle through, and I make sure the needle pushes out whatever's in the nozzle, and then I put 0 on the heat, and I hold the needle gently so it doesn't fall through, and then once the nozzle is heated down, cooled down, I scrape off all the excess filament of the needle that is sticking out at the bottom, so that nothing is left there. And then I put my extruder to the cold pull temperature, which is usually around 80 degrees, 80 to 90, and then I pull out the needle. I put a tiny pressure on the needle as I heat it up, and then I pull it out. Usually that helps removing those clogs. So yeah. Best practices to avoid clogs. Reduce volume speed. That is, calibrate, like this video is for. Calibrate your filament's max volumetric speed. I find that really important now after I had all these clogs. Use active part cooling. But I forgot to mention that. One of the things ChatGPT said was that if you're still struggling with your speed, then lower the cooling of your print. And that is why I had actually, for this tower test, you remember you saw all these layers here? That's why I turned off when I printed this. So 251st layer, that's like roughly here. And remember, the best ones were around here. It's not a coincidence. If you have too aggressive cooling with a 0.2 nozzle, it really has a lot of to say on the filament. So yeah, constrain that to. I think I printed this with what did I set the speed to? I configured that in the cooling settings, 60, max 70, and then I could see that at the bottom of the tower. At the bottom of the tower here, it was not using any cooling. So up to 250 layers around here, it wasn't using a coolant. Then it ramps up to 10%, 30, 20, 30, and then at the end it starts with 60. So I think for me that's a sweet spot of around 60% cooling on that filament. I think would be great. So you can use that to also keep an eye on your part, see which part is having a certain amount of cooling, and then you can sort of deduce from that what is going on. And let's see, use all metal hot end. These handle higher temperatures and reduce risk of cold plugs. Keep nozzle clean. Even slight carbon or char buildup causes the flow path faster in a small nozzle. Dry the filament. Most PLA expands in the nozzle, which can cause clog faster under pressure. So, as I said earlier, this video was to advise you people to start calibrating your max volume flow. I will leave in the comments or in the description, I will leave a link to my Excel sheet on my Google Drive. I will leave a link to the 3MF file so you can download it. I will put the 3MF file on I think I will just make it downloadable. If I put it on Maker's World, they would require it to be modified from Bamboo Studio, etc. You can do that yourself. Kind of short on time now. We are going to a small gathering. Anyway, I really love you people. I have reached almost my goal of 500 subscribers. So if you haven't already, subscribe and like this video. When I hit 500, I can monetize. Would really help me as a channel to be able to get on that. The next goal after that is 1,000. Then I can start making money on ads. I'm not doing this just for the money. I'm doing it because I want to remind me how to do stuff, and I also do it because I think it's cool, and it gives me a great hobby to do. So hope this video helps you, and if you saw it through the whole thing, I'm really impressed. But anyway, thanks for watching. Thanks to my loyal followers who watches my videos, and I'll see you in the next one.